Hi, my name is Elwin, and this here is Jeshrin,
Hi.
and this here is Zento,
Hi.
and today we'll be talking about our Van de Graaff experiment.
The aim of our experiment is to measure the number of electrons around the outside of the Van de Graaff using Coulombic force. Next, we'll be looking at the different parts of our setup. This experiment can be replicated on a much larger scale. For example, using this air-insulated Van de Graaff situated in the Boston Museum of Science.
This is the Van de Graaff that we're going to be using. This is a machine which transfers electrons from the bottom of the machine to the top of the aluminum dome. We're using a material which helps transfer electrons. There's going to be a certain number of electrons on top of the Van de Graaff. This banana clip right on top is used to transfer all the electrons on the aluminum dome into the wire and move it into the electrophorus plates. Theoretically, since like charges repel, there should be an increase in weight, which we will be able to see and read on the scale. Our variable that we will change is the distance between the two electrophorus plates. Our hypothesis is as follows. The force output will increase as the distance decreases. This difference should theoretically keep the number of electrons on the Van de Graaff the same.
Now, let's see this Van de Graaff in action. As for calculating the results of our experiment, we got the teacher to help us re-engineer Coulomb's equation to calculate the number of electrons of force output from our experiment. On the top right, we have our original equation, step 1 that we did, step 2, and step 3. At the bottom right, we have our final equation, and as you can see on our left are our results. That is the end of our video. Thank you for listening.